All right, thanks for having us. The next presentation will be myself. My name's Joe DeVore, and then I've got Austin Lovas joining me as well. We're with KLJ out of St. Paul, Minnesota, and just wanted to take this time to kind of talk about the benefits of doing a 24-hour daily traffic analysis using vSIM and how we've been able to kind of streamline the data process for that. As well as the results that we're getting out of it when we get into that alternatives analysis. So a lot of the kind of main reasons why we're considering a 24-hour analysis, whether it be an intersection control evaluation, a corridor study, we've even implemented it on about an 8-mile freeway study, is really looking at all of the daily volume instead of just looking at that peak hour analysis, which is just an 8 to 12%. Only probably roughly 20%, 30% of the delay happening within that AM and PM peak hour. And then looking at the safety aspect as well, understanding that crashes are occurring throughout the day. So just these are statistics for MnDOT. All of the state routes for one of our 77 or interstate studies. We looked at all the crashes happening within a 5-year period on that, and really found that there were peaks during the AM and PM peak, but really having a lot of kind of those midday crashes that were still a safety consideration. We wanted to look at benefits of possible alternatives at. So just a couple of kind of locations within Minnesota that we've implemented this. We've looked at kind of intersection control evaluations up in International Falls and Two Harbors. If you're familiar with Minnesota, there's a lot of cabin traffic coming out of the Twin Cities area, so Minneapolis, St. Paul, up north along Lake Superior, up north. Quite a few kind of touristy places in northern Minnesota, as well as up the 10 corridor up into the Fargo-Moorhead area. A lot of lakes around there. We've used it in kind of studies where we're taking a at-grade intersection and looking at implementing a grade separation. We've used the SSAM process to really quantify the safety of that. As there aren't a lot of crash modification factors going from an at-grade intersection to an interchange, especially when you start looking at what type of interchange you're looking at. And then we've also used it recently on a couple of 4 to 3 lane conversions, really quantifying the benefits of that 3-lane conversion, where we're actually seeing a lot of midday benefits or off-peak benefits, just getting those left turns out of the main travel lanes, and we're actually seeing less delay that offsets some of those peak disbenefits to vehicular traffic. So with that, I'll turn it over to Austin to kind of walk through some of our data analysis.
All right, so for 24-hour analysis, we have to have 24 hours worth of data at least, but FHWA recommends 48 hours count for most of our rural studies, which is a lot, about 90% of our studies. Which, because they don't have a lot of automatic traffic recording, which is mainly in our Twin Cities area, and which is your automatic detectors and cameras that are there 24 hours, 365. So we set up video counts for 48 hours throughout Minnesota, North Dakota, South Dakota, Montana, and Colorado, which is our market area. We also have to go into consideration of events, recreational peaks, and trucks. This example is for our northern Minnesota one in International Falls. We had a lot of winter logging routes coming out of. Oh, there's pointer. Okay, a lot of logging trucks going out of this east side. This south, or this lower right, is all the logging between this is logging, this is all trucks, all other trucks, and then just daily or your all your rest of your traffic. And next slide. Okay, we also collect our streetlight data for to implement seasonal adjustments where we can't do it in the field. So you collect a year up to 2 or 3 years sometimes, and we can see here by we usually bin it into 12 months or monthly bins and see how different between 32% below and 32% above your mean annual your daily traffic here. And we also quantify it between your 2019 pre-COVID and current, depending on your rural versus your urban. They definitely have different demands and definitely have different patterns depending on where you are in the state and in the nation. Next, one example of our validation for streetlight, we had counts in 2017 September or March rather. We saw a high number of westbound right and southbound left traffic, and we compared it to 2018 to 2021. We saw, and we had to realize that this high number is from a closure of a bridge back in 2017 where there was flood in southwestern Minnesota. So we had to bring these numbers quite down to match our streetlight data, which was more in the 800, 900 versus your 1600. And this also saw another closure for construction. Construction, was it? Yeah, construction back in 2019. Next slide. Breaking down our, this is our spreadsheets that we input into VSEM with your hourly on top and our nodes on the left side. All your turning movement counts broken down by your intersections. With this specific project, we had some peak hour counts in infield counts, and this had a full 13 hours count, and then we implemented your street light, which is your yellow, to complete your data set for this 13-hour project VSEM model. And along with getting your counts, we compared it with our MnDOT ADT to see how well, if it's higher or lower than what MnDOT says it's normally at. And then our next thing we do with our data is implement a PHF factor depending on the project. Sometimes we do it for peak hours, AM, PM peak hours. Sometimes we've done it for the full 24 hours. We see definitely for this specific project a high peak hour factor in your AM and in probably 3 PM. And so this definitely makes a difference in your modeling results when you get back to the model runs when we do get those finished. And then we had a cluster analysis. It's a little different from what we had. This is based on a Minnesota highway. You just have to look at different how the demands are different between our clusters. We pretty much looked at a weekday, a Friday, a Saturday, and a Sunday. Each day had a different pattern. Weekday was this is a corridor which was a heavily fairly heavy recreational peak, tourist peak with your Friday northbound and Saturday is southbound heavy traffic. Saturday is a mixture of both, and definitely saw a difference in each of the days, whereas Sunday had a really big peak in your midday and Saturday later on. We use this to compare level of service between days, your network comparison, travel times, all your different safety benefits to their SSAM data as well. And then I'll hand it over to Joe and finish off the rest.
I'll just make one more point on this figure is really separating out where those hours of deficiency are and communicating that with clients really helps them compare back to existing, understanding that, you know, these are 4 to 6 hours of recreational peak delays where we're giving them a alternative that's taking that down to, you know, a single failing hour and a couple hours where you're still going to have some of that increased queuing. And so we use this graph a lot with our MnDOT team to really feel comfortable in recommending a single lane roundabout for safety reasons and not really having to build it as a multi-lane roundabout from day one. Another thing for kind of modeling a daily analysis really is signal timing. And so on a lot of our urban routes that are signalized corridor, we actually have to implement all 24 hours of that timing into one signal controller in VSIM. And so we take advantage of the different patterns based on when that pattern start time is in our simulation. We have 8 possible patterns. For the most part, a lot of our agencies aren't putting in more than 8 patterns throughout the day for a certain day. We also are implementing different phasing for left turns throughout that daily period. And so that's a little bit of a clunkiness in VSIM right now, where you can't change between having protected and protected permissive throughout the day. It's always got to be protected permissive unless you're kind of tricking the model with priority rules to restrict those permissive movements during specific times. So talked a lot with the PTV team already about that. Hopefully a future version addresses that and makes it a little easier to move between protected only and permissive. So how are we kind of using this 24-hour model? And latent demand is a big one where we can see going from existing to future conditions and looking at quantifying what that latent demand is in some of our static vehicle models and really looking at what the constraint points are going to be in a lot of our corridor studies. And so in the real world, the latent demand represents displaced trips. Trips not taken or lost business, but in VSIM, it's really backing off of those links, not getting into the model during certain periods of the day. This was one of our major corridor studies up in St. Cloud, where we ended up having a lot of displaced trips just because our corridor was at capacity, and we really wanted to quantify what that existing capacity of the corridor was and what the latent demand was going to be funneling into it over the next 20 years in our analysis. And so we also we have to look at where this kind of micro simulation 24-hour process is important to implement. And so when we're looking at a macro simulation or synchro or vistro, or in this case Rodel, we're really looking at that volume to capacity under 0.8 or 0.85, where we're in that level of service A to C range. Deterministic tool like that usually gives good results, but as you start getting into these situations where you have a peak hour factor pushing it over that, where you're getting closer and closer to capacity, that's really where micro simulation shines. And when VSIM really shows some benefits. And so in this instance, our Rodel results were actually showing level of service D for the hourly results, level of service E for the 15-minute results. And MnDOT was taking that as acceptable to implement a single lane roundabout. However, what we saw when we took a look at the kind of comparison between Rodel and VSIM and the differences between micro and macro simulation is because Rodel was modeling that volume over the capacity threshold for that 15-minute period, showing that it was just averaging the 4 time periods. It was under that level of service F capacity in that D to E range, whereas VSIM, once you hit that capacity, that breakdown capacity, it limits your capacity to where all of that additional volume ends up being latent delay throughout the rest of the period. And so we were able to work with the stakeholders to understand that this 2-lane highway was going to have some of those queuing effects with the implementation of the single lane roundabout, and that we'd likely see more delay during that AM peak hour. And so just kind of being able to visualize that with stakeholders, we ended up getting kind of a second lane through this roundabout in our eastbound only direction, and really showed the benefits of that over the next 10 years. As we start getting into kind of the overall results of a 24-hour model, traffic operations is a big piece that we're pulling out. And we do a lot of network delay and network VHT in our comparisons between existing, future, and then build scenarios. And so in this example down in the lower left, we're actually looking at travel times along one of our 4 to 3 lane conversion corridors. And we found that, the eastbound and westbound travel times, your 50% for kind of the daily average was in kind of that 5-minute period, whereas our peaks were getting into that 9-minute period. But when you start looking at the amount of delay even happening in kind of the average results throughout the day, we found that the peak hour results were only about 20% of the delay that was happening on that 4 to 3 lane conversion project. And there was a lot of benefit through delay reduction throughout the rest of the day, possibly, or at least mitigating what was added if we were going to those 3-lane sections, adding in our multimodal, trying to limit that delay increase during those off-peak hours as well. As I said before, we have been looking at using this for SSAM as well. For SSAM, comparing it against crash rates, it's a lot easier to do on a daily level. During peak hours, you get anywhere from 15 to 25% of your conflicts happening within a peak hour versus the number of conflicts happening throughout a day. So in a lot of our VSIM models, we're really looking at the 3 main types of intersection conflicts: rear end, angle, and sideswipe. Really looking at how we're addressing those with our specific alternatives. And so for the signalized models, we're looking at what's safer: a protected phasing, protected permissive, or permissive phasing. For rear ends, whether we're implementing signals, roundabouts, how we're reducing congestion in the model. And then sideswipe for the 4 to 3 lane conversions. If you're going from a 2-lane link to a 1-lane link, you're reducing a lot of those sideswipe type crashes. And so when we're looking at a 24-hour period, we're actually seeing a lot of benefit during those off-peak hours with roundabout intersections. And so we've done this as a way to kind of help justify roundabouts and give more of a site-specific benefit to roundabouts, even 2x1 roundabouts, where we're actually seeing decreases in conflicts, whereas you're also going to decrease the speed of those conflicts, lowering your severity rates at those intersections. And so looking at, being able to mitigate those fatal and severe crash types, we can look at those specific crash types that are decreasing, the crossing conflicts being the most severe, followed by rear end, taking some of that existing data and really have a crash cost associated with each of those CMF reductions for crossing, rear end, and lane change in each category. And so all that allows us to bring it into a benefit cost analysis. And so instead of trying to take peak hour results and manipulate it into daily results, we have all of that operations and safety benefits, VHT, delay, and we can bring that directly into a daily. If we have different scenarios, we can match up those scenarios with their frequency throughout the year, and we can create a very detailed benefit cost analysis that we can then submit to USDOT or MnDOT as a comparison between projects and really justify these projects. One example here was the International Falls one that had a lot of truck traffic. We didn't have a high existing safety issue at that intersection. We instead had to look at a 90-foot logging truck not stopping at a stop sign, because if they stop, they have twice the acceleration time to get across that intersection. So they were making a decision about 50 feet back from that stop sign if they were going to go through or not. And just the interaction of a logging truck and a 60-mile-an-hour state highway vehicle was enough to justify the kind of proactive safety benefit of the roundabout intersection. So just in summary, we've found that it's about a less than 10% increase in time going from 2 peak hour models up to a 24-hour model. And really that is only having one model. Working through, as Austin was showing with the volumes, where we do kind of that first time period, and then we're able to kind of pull those equations to the rest of the 24-hour models. We're able to validate those volumes better, being able to compare them back to ADTs, catch some of those volume discrepancies quicker than before, such as the 22 example, where we can quickly identify that, no, these volumes are a lot higher than the normal case for this intersection. And what that allows us to do is really fit the optimized alternative improvements to each of our study locations. And so with that, I'll take any questions.